there and welcome to the Screencast. Tonight I'm going to solve some of the problems you might see on tomorrow's quiz on function operations. In the first problem here, I'm asked to find the product of two functions. So I'm simply going to multiply the two functions together and we'll see what I get. Okay, so both of my functions are binomials, so that means I'm going to have to do first, outer, inner, last. So let me do first, outer, inner, last. The firsts give me negative t cubed. The outers give me 2t. The inners give me t squared. And the lasts give me minus t. Then I'm just going to reorder the 2t and the t squared to put them in so that the entire expression is in standard form. And that's my result. Okay, the first few words in tonight's secret phrase are: last month, Netflix reported. Alright, in the next problem, this time I'm multiplying the first function by 2, and I'm also multiplying the second function by 2, and then adding. So let me write that all out. So 2a squared minus 5a plus 2 times 2a minus 4. So now I need to distribute and combine like terms. So I get 2a squared minus 10a plus 4a minus 8, and I can combine the middle two terms, leaving me with negative 6a minus 8. And the next few words in tonight's phrase are that it lost 810,000 subscribers. Alright, moving on. Number 6, I'm asked to find the composition of two functions. So I always start with the lower function, and I'm going to substitute it in to the function that's above it, or that's the outer function in the composition syntax. So now I'm going to, instead of having 3a minus 4, I'm going to have 3a squared plus 3 plus 2a minus 4. Then I just need to distribute and combine like terms. So when I distribute, I get 3a squared plus 9 plus 6a, and that would be minus 4. Sorry, it's getting a little rough there. Let me make sure I'm doing that right. Yeah, 6a minus 4. And if I combine the 9 and 13, I get that, and that is what I'm aiming for, and I'm done. Okay, number 8, I'm substituting in a value in for the variable in the lower function. So I take 7, I put it in f wherever the variable occurs, and I do the math. So when I do that, I get 7 squared minus 4 times 7, and that gives me 49 minus 28, and 49 minus 28 is 21. Alright, now I take the 21 and it goes in for the variable above it. So I get 3 times 21 minus 4, and that's 63 minus 4, and that is 59. And I am all set. 59 is what I'm aiming for. And the next few words are in the third quarter. Okay, now I'm asked to do the composition of a function with itself. So when I do that, I always want to write the one function, write a copy of the one function right underneath itself. So in this case, I'm just going to write one above it. And now I take the function itself and I substitute it in for the variable in the other function, which just coincidentally is the same function, which is okay. It's what you need to do. So I get -3, and now instead of a squared, I have -3a squared plus 5a squared, and then plus 5, and then instead of a, I have -3a squared plus 5a. Alright, I'm going to spare you the details of foiling -3a squared plus 5a, but when you multiply that, you need to do this. You need to actually foil it. Okay, so I need to write it out, foil it, and then combine like terms. Okay, that's what this is actually equal to. But I'll spare you spending the time showing that to you. I'm just going to give you what the answer is. So when I FOIL that, I get 9a to the 4th minus 30a cubed plus, let's see, 25a squared. And that is, let me distribute in the second expression. I get minus 15a squared plus 25a. Okay, now I need to distribute the -3. And that's going to give me -27a to the 4th plus 90a cubed minus 75a squared, and that's minus 15a squared plus 25a. And lastly, I'm going to combine like terms. I can combine those two. So my final result is this. It's 25a. And, oops, I'm all set. Alright, the next few words are in the third quarter. Okay, now I'm asked to find the inverse of a function and verify that it is really the inverse for these three functions. Now I'm only going to do the verification once because otherwise this podcast or screencast will go on forever, which I don't think anybody wants, including myself. So to find the inverse of the first function here, the first step is always to put the x where the h of x is and the h of x where the x is. So I just rewrote the function, switching the locations of h of x and x. And now I need to solve for h of x. So I treat it like a variable as if I were solving for it. And to do that, in this case, I can see that I have the third, because I have the third power, I'm going to need to take the third root of both sides of the equation. And that's going to cause the cube or the third power to disappear on the right and leave me with this. And then the final thing to do is just to add 1 to both sides. And I get h of x is equal to the cube root of x plus 1. And then I need to add the -1 to denote that it's the inverse. Okay, so that's the answer to the first part. That's finding the inverse. Now, for this one, I'm going to actually confirm that it is indeed the inverse. And when I do that, I need to find h of h inverse x and h inverse of h of x. So it's so there are two composition problems, just like the ones above that we just did. And I want to check to see that those are both equal to the variable, which is x itself. All right, so let me me do the first one, h of h inverse of x. So for that one, I take h inverse of x and I put it in to the equation wherever x occurs. And I check to see what I get. So if I do that, the rest of the h of x stays the same, except instead of x, I'm going to have the cube root of x plus 1, because that's what my h of x is. So now I need to simplify, and when I do, I can see the 1's drop out, and then I'm really left with the cube root of x cubed. Well, those are reverse operations, so that leaves me with x, and that's what I want. So that one checks out. Okay, now I'm going to go the other direction. Alright, now I'm taking h of x and I'm substituting it in for x in h inverse x. So when I do that, I get, let's see, cube root of, and instead of x, I'm going to put x minus 1 cubed, and then plus 1. And let me do the highlighting to show you. Oops. Alright. This pen is not doing so great. Okay, well, I can see that the cube root of x minus 1 cubed, those cubes are going to cancel each other out, and now that's going to leave me, after I drop that, I'm left with x minus 1 plus 1. Well, x minus 1 plus 1 is just equal to x, and that is the result I'm looking for. So that tells me that the inverse I found does check out, because when I do the test, it passes both tests. So, alright, so that's 14. And the next few words in tonight's sentence are, and said that it expects to post a global net. Alright, 16. So to find the inverse, first step, switch x and g of x. Okay, the next step is solve for g of x. So in this case, I'm going to do that by multiplying both sides by 4. That gives me negative g of x plus 1 equals 4x. Okay, next I subtract 1. And now I'm up to negative g of x equals 4x minus 1. And then the last step, divide by negative 1. So I get g of x, and now I'm going to add the negative 1 symbol, equals, and that's 1 minus 4x. Because that's negative 4x plus 1, which is 1 minus 4x. And I am set. Alright, and the next few words are loss next year. Ooh, did I skip one, or did I do the last one? Oh, I see, yeah, I skipped doing number 12. Okay, well, let's do number 12 then. Alright, I'm going to switch n and f of n first. So, and when I do that, the negative sign is going to stay where it is. Okay, now I'm going to subtract 3, leaving me with n minus 3 equals negative f of n. And then I divide by negative 1. So that gives me, I seem to keep saying, there we go, that's better, gives me f inverse of n equals negative n plus 3. Now in this case, it turns out the inverse is the same as the function itself, which is possible. And if you did the check of doing the f inverse of n versus f inverse of f of n, you'd find out that they were both equal to n, and you'd really have found the inverse. Alright, hope this screencast was helpful, and get a good night's sleep, and we will see you tomorrow. Cheers.